Hi everyone! In this video, we're going to talk about various ways in which the trigonometric functions are related to each other. In other words, we're going to explore some trigonometric identities. So an identity is an equation that is true for all values of x or theta. Some trigonometric identities you already know. I am talking about the reciprocal identities. You know that secant of theta is the reciprocal of cosine function, so it's 1 over cosine of theta. Or we can say that cosine of theta is the reciprocal of secant. We know that cosecant of theta is the reciprocal of sine. And in its place, sine is the reciprocal of cosecant. And the last one is cotangent. Cotangent is the reciprocal of tangent, and vice versa. Tangent is the reciprocal of cotangent. There are also two identities, they're called ratio identities, that you're probably familiar with. They relate tangent and cotangent functions with sine and cosine. Let's see where those identities come from. We know that the xy plane definitions of sine and cosine are the following. So we know that sine of theta is defined as y over r, and cosine of theta is defined as x over r. What happens if we find ratio of sine over cosine? So sine of theta over cosine of theta. Well, sine is y over r, cosine is x over r, and now we have this complex fraction. To simplify it, we take the numerator fraction and multiply it by the reciprocal of the denominator fraction. As we can see, r's will cancel, and we're left with y over x. But now what is y over x? That is tangent, right? Tangent of theta, that's the definition, again, xy plane definition of tangent. And now if we look at where we started and what we ended up with, we're going to see that identity. So tangent of theta is same as sine over cosine. I'm going to write it here. So tangent of theta is sine of theta over cosine of theta. That's one of the ratio identities. And the other ratio identity is for cotangent. We can either obtain it by taking this long way or simply taking the reciprocal of tangent in what it equals to. So reciprocal of tangent is cotangent, and reciprocal of this right hand side is cosine over sine. So that's the second ratio identity. There are also several identities that are based on the Pythagorean theorem. As you remember, if we pick a point on a circle and connect that point with the center of the circle, well, that creates radius, and then construct a right triangle, well, with the sides x and y and r, then sides of this triangle and therefore coordinates of the point and the radius can be connected by the Pythagorean theorem. And what I'm talking about here is the equation x squared plus y squared equals r squared. Well, that is the Pythagorean theorem applied to the triangle. What I'll do, I'll manipulate this equation a little bit. I'm going to divide both sides of this equation by the same number, by the same quantity, and that's going to be r squared. So I'm going to divide the left-hand side by r squared and the right-hand side by r squared. When we divide by the same number on both sides, then equation stays true. Okay, well, now on the left-hand side, I'm going to divide each term in the numerator by r squared. In other words, I'm going to separate the left side into two terms, two fractions. So that's going to be x squared over r squared plus y squared over r squared. And on the right-hand side, it's r squared over r squared. Okay, now next I'm going to write each fraction as a quantity squared. So let's say for the first fraction it's the numerator squared and the denominator squared, I'm going to rewrite it as fraction x over r and then square outside. Well, we can always simplify it and go back to the original version of it, right? I'll do the same for the second one, y over r squared. And now on the right hand side, I don't actually need to do that because I can see how the right hand side equals 1. Okay, going back to the left hand side, what is x over r? Well, we just refresh that. X over r is the cosine, and then y over r is sine. So what I'm looking at is cosine of theta squared plus sine of theta squared equals 1. It's actually common if we're squaring or raising a function, trigonometric function, to a power, to put that power not necessarily outside and use parentheses as I just showed, but put it right next to the function name. So I'll write like that: cosine squared of theta plus sine squared of theta equals 1. And what we're looking at is the most basic form of the Pythagorean identity. This is the most popular identity in the trigonometry. So it's worth being written on a side and boxed. And from here, from this identity, we can obtain a few other versions of the Pythagorean identity. Let's look at them. So the most obvious step that we can do as we try to obtain different versions of the Pythagorean identity is to either isolate cosine squared of theta or sine squared of theta. Well, let's do one at a time. If I want to get cosine squared of theta by itself, I need to get rid of this sine squared, so I'll do that by subtracting sine squared of theta. Here I copied that basic identity one more time, and as I said, I'm going to subtract sine squared of theta on the left hand side and on the right hand side. Okay, so sine squared goes away, and I'm left with cosine squared of theta equals 1 minus sine squared of theta. And that's another version of the Pythagorean identity. And you may guess that getting sine squared of theta by itself is pretty much same thing, right? We'll have to subtract cosine squared of theta from each side. So from there, I'm going to skip those steps, but from there, I will get the following. Sine squared of theta equals 1 minus cosine squared of theta. Like that. So those two, come very useful in certain stations. Okay, so what else we can do with this sine and cosine Pythagorean identity? Well, let me show you. I'm gonna rewrite that identity again. Cosine squared of theta plus sine squared of theta equals 1. And what I'm gonna do next, I will divide every single term of that identity by, let's say, cosine squared of theta. So it's the same as dividing left and the right sides by the same quantity. So in this case, it's cosine squared of theta. Okay, so let's try to simplify it a little bit. First of all, I can see that the first term equals 1. Now, for the second term, I'm going to write it as a quantity squared, so I'm going to pull that square outside. So it's sine of theta over cosine of theta squared. And I'll do the same thing on the right-hand side. It's 1 over cosine of theta, and the whole thing is squared. You can always apply the square and see how you go back to the previous step. Do you recognize some parts of this identity? What is sine theta over cosine theta? Well, that is tangent. We just refreshed that, right? So I can rewrite it as 1 plus tangent squared of theta, square is still there, equals, now how about 1 over cosine? Do you recognize that one? That is secant. So it's secant squared of theta. And that's another version of the Pythagorean identity. Here it is. That's the one that relates tangent and secant. So 1 plus tangent squared equals secant squared. I can also manipulate it. In this case, secant squared is by itself. Well, I can get tangent squared by itself. Just to modify it slightly. So I can subtract 1 from each side, and I'll get the following. Tangent squared of theta equals secant squared of theta minus 1. Here's an identity that relates tangent and secant. Again, well, similar one, but in this case, tangent squared is by itself. And now I'll obtain two more versions of Pythagorean identity. They're going to be similar to the ones we just looked at. So I'll repeat the steps in a sense, but this time I'm going to divide by sine squared instead of cosine squared. So let me rewrite the original identity. Cosine squared of theta plus sine squared of theta equals 1. And now I'm dividing by sine squared of theta on the left hand side and on the right hand side, but that's same as dividing every single term by sine squared of theta. Okay, so what do I see here? Cosine squared over sine squared. Well, I can write it as cosine theta over sine theta squared. Now, next term is 1, right? Sine squared cancels, so I just get 1. And on the right-hand side, I'm going to put it as 1 over sine theta, and then the whole thing is squared, like that. Now, what is cosine over sine? That is cotangent. So here I'll get cotangent squared of theta plus 1 equals, and then 1 over sine, that's cosecant. Oh, and of course it's squared, right? That's squared here. Well, here's another version of the Pythagorean identity. In that version, cotangent and cosecant are related. And we can see how cosecant squared is isolated. If I want to rewrite it so that cotangent squared is isolated, I'll just have to subtract 1 from the left side and from the right side, and that's what I'll get. Cotangent squared equals cosecant squared of theta minus 1. So these are the most common versions of the Pythagorean identity, the ones that relate tangent and secant, cotangent and cosecant, and of course the ones with sine and cosine. And everything starts from this most basic one, cosine squared of theta plus sine squared of theta equals 1. Knowing this identity, you can derive the rest of them, as you can see, in a pretty easy and straightforward way.